Alright, I'm going to start. Cool, so today we're going to talk about the mobile wallet attack surface. Everyone uses mobile wallets with your Bitcoin. You probably don't even know what's going on there. You just trust that Apple and Google are taking care of all your data. But yeah, so as me, most of you guys know me. I'm Oscar with Fedi, the engineering lead, and yeah, so some of the stuff we're going to talk about is the operating system architecture. So we're going to learn about what the operating system does, what writing to disk, memory, the difference between them, what the operating system does to protect you, to make it easy for developers, for example. Keys, how they get generated, how they get handled. This boundary, this application boundary between native apps and the web. And we're going to talk about Fedi mini apps. So the goals, I just want to build some more awareness of what mobile apps are doing when we install and use wallets, what's going on under the hood, some technical learnings, hopefully. I want to share what we're doing with Fedi mini apps. There's some new developments, some future developments that might be interesting for anyone developing websites. And so yeah, we're going to talk about how to do that securely. So I think we might not need that much of a crash course because we have some Fedi people. Maybe I'm going to go through it anyway, so just in case you don't know what Fedi is, you don't know what eCash is. Fedi's a mobile app, it's a global startup, there's a lot going on, we're doing a lot of different things. Very general, high-level goal is just empowering humanity with freedom technology. That's like our mission statement. It boils down to a digital wallet from the technical sense. We've got Bitcoin, Lightning, Nostr, end-to-end encrypted chat, eCash is all in here. And so Fedimint, we basically depend on Fedimint. There's a lot of interesting technology that Fedimint is doing under the hood, and so Fedi lives on top of that. We're just trying to make it easy to use Fedimint and eCash. If you've heard of Cashew, it's just a federated version of Cashew. Instead of one single server, you have multiple servers. One can go down, and the system keeps operating. So that's kind of Fedimint in a nutshell, if you're not familiar. Just quick show of hands, who knows what eCash is? Okay, so we have already some knowledge about eCash. So yeah, at the end of the day, I like to put it as a custodial multi-sig with privacy included. So if you're going to give up some custody, at least you might be able to get some privacy out of it. Our tech stack at Fedi, we have React Native, we have Rust, cross-compiled into native code, Kotlin for Android, Objective-C for iOS. We have this thing called an integrated web view. We'll talk about that more in a bit. Lots of cryptographic operations, Fedimint and Matrix, both. Matrix is what we use for the end-to-end encrypted chat. And then lots of server communications. It's like I said, it's a federated system, so you can have, with one federation, you're talking about 4 guardians. If you have 3 federations, you're talking about 12 potential server connections. Then you've got the Matrix server, there's just a lot of server communication. So yeah, this is just like the landscape of, the technical landscape of what we're dealing with Fedi. These are just a couple of the screens if you haven't seen them yet. Here's the chat, communities, mini apps. We're going to talk about mostly about the mini apps, and then federations you can join to get wallets. So yeah, first thing we'll talk about is on-device key generation. So obviously in the app you have your seed. You back up your seed, and how does it get generated in the first place? This is something that you are trusting the operating system to do. The operating system provides a random number generator, and I think these days there's not many vulnerabilities in the random number generators at the operating system level. You gotta be like a pretty hardcore, paranoid person to kind of need something that goes beyond generate entropy outside of the phone. I think it's pretty secure here, but obviously you're trusting the operating system for this. And we use the random number generator to generate the entropy that generates the seed. And then everything, I'm going to jump ahead here. Yeah, probably should put these in a different order. But so everything comes from the seed. There's one single master seed phrase. It deterministically derives everything else that you need. eCash notes, that's cryptographic signatures, all derived from the seed. Lightning payments, generating invoices, anything that you need to derive its private key material, we'll just use the seed for this. That includes the Nostr identity, the ended encrypted chat. So basically, if the seed gets compromised, everything gets compromised. There's no like, oh, well, they only got a hold of this key and not that one. Like, we just put everything in one place, and you can think of it as, it's a little scary maybe, but, slide for that. Okay, yeah. But I mean, you get the idea. We actually, I thought I had there it is, okay. So yeah, this is great for recovery. So you can take the seed, put it into a new device, and then everything that you need, you can just derive from the seed. It's a little scary if it's compromised, but again, just make sure it doesn't get compromised and you're okay. Not so fun fact, an early version of Fedi did have one seed per federation. And this is why we were like, what the hell, if I joined 3 federations, I have to back up 3 different seed phrases. That's just a non-starter. We ended up, this is one of the earliest projects, one seed to rule them all, we called it. So yeah, backtracking a little bit here to talk about the operating system architecture, right? So the operating system, you download an app, it's a bunch of source code, and it's the runtime environment, the code is executing, you have disk and you have memory. You have your RAM and you have your storage, right? So one of the things that we trust the operating system to do is isolate the apps. And basically this means that Fedi, as it's operating, no other apps can access the memory or the file system that Fedi has access to. And I mean, this is very important for our security assumption, but it's very common. It might surprise you to think, like, it's funny, I was in an engineering meeting the other week, and I was just kind of brainstorming. I was like, we're working on a feature to authenticate, basically allow guardians to authenticate in the app. And we were like, all right, where's this needs to be secured. Are we encrypting the seed when we store it to disk? And one of our engineers was like, no, it's stored in plain text in the database. I was like, oh, that sounds scary, but it's really not because of this. It's isolated. I mean, if we can't trust the operating system to enforce these boundaries, then like there's a whole lot of other stuff that's broken. So it's okay in the sense that it's stored, the seed is stored in plain text because no one can read that. Only the app can read it. If you want to think adversarially in all these exploits, it's the theme of the conference. You might consider, okay, well, if it's stored in memory, what happens? Can something get access to it? It's like, basically at the end of the day, no, the operating system enforces these boundaries. The one thing I want to point out is rooting your device. I think there might be a group of people in this conference, if anything, they like rooting devices. So I would not recommend using Bitcoin wallets on a rooted device. That's where these assumptions are thrown out the window. And honestly, something I would like to know is just how many different Bitcoin wallets are taking advantage of this assumption. Because there's obviously other ways you can secure the key material. But anyways, this is more or less one of the things I wanted to share here. This other aspect of when network calls need to be made, that is actually regulated through the operating system as well. So the app process makes a system call down to like the kernel, and then there's a whole bunch of protections you get when you're making network requests. For example, is the certificate valid, HTTPS versus HTTP. So yeah, network requests go through the kernel, we get some extra protection there. Like I mentioned, all bets are off if you're on a rooted device. All this kind of breaks down. And so yeah, with Fedi, we're operating under this assumption. Already talked about this. So the other interesting piece is, so the seed is stored on disk. When you visit this screen in the app, right, what will happen is the native code will read the seed from disk. It will allocate some memory, because whenever you're programming, you want things in memory, your variables are all there, and you want to display them on screen. Now, the seed is in memory. But again, you're in your protected little sandbox. It'll get garbage collected eventually. And memory heaps generally aren't dumped to disk if like the app crashes. Just another kind of fun mechanic there on keeping in mind where you're storing sensitive data. So this one, this could be like a whole rabbit hole. I don't think I'm going to spend too much time on, but this would have been kind of if we wanted to harden the security of the app. If we wanted to say, well, what about I mean, rooted devices, what kernel exploits are all this? Like, how can we protect ourselves against these situations? The secure enclave is something that you do have access to. We don't use it for anything other than the PIN. So if you use the Fedi app, you can set a PIN, and the PIN is actually stored in secure enclave. We've considered using it to maybe harden security a little more. There might be something there. You're going to get some extra complexity, especially when transferring devices. Yeah, when you're,
Yeah, I was going to ask about the secure enclave. I know with Bitcoin, like, you can't do it because they don't have that curve.
They don't have the what?
They don't have like the secure enclave that most devices use. They wouldn't have the curves that are used for transactions.
Interesting.
But with if you had eCash notes, they could use the curves that are available to the secure enclave. I guess you could remove it ever being in memory. But I assume there's extra complexity. But I know like there's different apps that use this more like on the crypto side of things because they can just patch in and use the curve that the secure enclaves use. Maybe that can be used for the eCash notes, but maybe it's also not worth it for the
I mean, I think there's a bunch of solutions here to just, if you're just thinking about how to improve this security model. We're writing things to disk, things are in memory. Sensitive things are in disk and in memory inside of the sandbox. If you want to remove the assumption that the sandbox is safe, maybe there's ways we can use a secure enclave. Again, I think a little bit of unexplored territory, but we have considered it. It basically uses a completely different compute chip, so like the kernel isn't necessarily performing in the same way, subject to the same mechanics, but yeah, any isolation bugs, it should give you some extra security. But yeah, I was just tinkering with the idea, like, what if you encrypted the database, and then the decryption key could be seed derived, and you put that in the secure enclave. But then, like, what if the database changes? You're encrypting it every time the database changes. I was like, no, well, maybe just the seed phrase, if anything, you could do something there. So, but I don't know. I think we haven't explored it too much, but this is an option. This is available. There's APIs that are available to take advantage of it. But yeah, last thing, important thing, accessibility settings. I don't know if you've downloaded apps like, I have one on my phone that like monitors my screen time. It's like tries to block me from scrolling Instagram, but I have to grant it accessibility. I have to grant it the ability to see what I'm doing on the screen. And so this can be a risk. If you grant any apps on your phone accessibility, even like the floating window one, like it can technically it might be able to fool you. It might be like detect what's on your screen and then show you something that is trying to trick you in a way. So you want to be careful if you're granting apps accessibility permissions. There are some flags that actually we need to add to our seed phrase screen. So that if you have other apps that grant accessibility, there's a way to basically tell the operating system that there's sensitive things on the screen, and if it granted any accessibility permissions to other apps, that they shouldn't be able to access what's on the screen. So yeah, something to keep in mind if you're an app developer. So in summary about operating system type things, be very careful with your Bitcoin wallets on a rooted device. Totally trusting the devs from build iOS and Android with your life savings if you're putting any money on there. But yeah, for entropy and isolation, basically. Consider using the secure enclave. I think that's about it. That's about all I wanted to cover there, unless questions about general operating system mechanics. Hopefully, learn a little something interesting. So now we're going to dive into this, basically layer on another assumption on here, right? So the Fedi Mini Apps browser, we're talking about something called the web view. And so web views, they provide you have native code for accessing the web, basically. So apps can use this to create browsers, which is something we have in Fedi. We have a browser, basically. So this is an example of E4OS, the website, loading within Fedi. That's all it is. They're websites. We do add some extra JavaScript to the web view. So if you look at the code, we render the web view and then we inject some customized JavaScript. This is so that we can enable WebLN, NIP-07, and then a few Fedi APIs that we want to continue evolving. We haven't had a ton of time to flesh this out, just with all the other things that we're working on. But we think we want to make this a super robust experience with a lot of capabilities so that any website can kind of tap into the Fedi functionality. So this is our current version. The key thing here in terms of security and exploits is this confirmation, right? So the user is their own worst enemy here. They see the security profile of this system is such that, yes, you're trusting the website, because the website can also run any JavaScript that it wants, and it can kind of call these APIs in whatever way that it wants, but really it's going to be about tricking you. It's going to be about tricking you into thinking that you should be paying for something, but the actual authorizing of the payment, that is still running native code. So getting into a little further, let me just still stay at high level here in case you're curious what a mini app does. You can do lightning payments, you can do Nostr identity and signing, and you can get the user's preferred currency and language using these APIs. You can do this today. So yeah, from the user's perspective, opening a mini app feels like opening a page in the browser. You don't need to install anything special. You just need to be aware of, I guess I just skipped over that, did I didn't add a slide for that. We just need to be aware of these little, we attach things to the window object, basically. Window.WebLN, you want to make an invoice. If you're a mobile app and you want, or sorry, if you're a website, you want a way to either get money into your user's wallet or out, you would use these WebLN APIs. If you want to get their Nostr identity, you can do that. If you want to sign events, so that you can do whatever Nostr things. I'm not super familiar with all the Nostr use cases, but you can sign events. You can encrypt events. You can do encryption and decryption. NIP-44 is the one you should use. NIP-4, if you've heard the talk up there just now, is not. It's going to be leaking metadata. So don't use NIP-4 if you're doing Nostr stuff. Again, don't use NIP-4. We didn't have NIP-4 in here. We didn't support NIP-4 because we were like, oh, that's not secure. Why would we subject our users to, or why would we open up the path for them to leak their privacy? We didn't want to do that. And then we realized a bunch of websites were using NIP-4, and then at the end of the day, you use the Fedi app, and it seems like it's broken. So then I reluctantly was like, okay, fine, add NIP-4, add something that we shouldn't, that users shouldn't even use to the app, just so the experience is less broken. If no one uses NIP-4, then we don't have to do that. So I'm going to use NIP-4. The custom Fedi APIs, you can get the currency code, get the language code. So yeah, this is nice if you're operating in a different country with a different currency. If the user has set their language in Fedi, you can pick up on that and customize the experience of your mini app accordingly. This is something we are in the process of adding, which is a little bit of a exploit, kind of fun fact. Right now, you can just get the user's pub key without their permission, which is not ideal. We want to put the user in control. And so if you are considering using any of these APIs, just read these docs. There's a link at the bottom here. I'll make sure this is prominently featured, but don't assume that you have access to this. You want to design for the user rejecting it. This shouldn't be too complex to do that. But yeah, once we remove those, once we put those behind permission gates, we're going to make our best effort to reach out to mini app developers and say, hey, make sure your app doesn't totally break. But yeah, this is something we're in the process of adding. It's technically in production, but we still need to, there's still a little bit more work to do there. Let us know if you have any ideas about what APIs might be helpful if you're building a mini app and you want access to the Fedi user base, because there's a bunch of people using Fedi, and if your website is useful to them, then we can put it in front of them, and if it works well in the browser, then that's great. Last little technical bits here. This is kind of showing you the flow of how that experience works. So the web view, when we render this JavaScript, we set this flow up. So what the page will do is it'll call window.webln.generate invoice, and so we use this browser API called post message. That gets sent up through the web view. We figure out what message it is. and we either trigger an overlay if it's one of these sensitive things like making a payment, or there's some silent operations where you wouldn't need user interaction. These will probably go away, and there's going to be, at the very least, always a permission overlay. But yeah, there's obviously stuff happening in the background and stuff that you have to wait for the user to confirm that they want before moving on. And then we send that back into the web view. So the important thing I wanted to point out is that this JavaScript context and this JavaScript context are isolated. So this is another thing the operating system does for us. So that JavaScript running from any random website can't do things like pull things out of the file system. So yeah, it's another fun fact about how the operating system works. This is your app sandbox. The native process that renders that web view is totally separate from the JavaScript running in that web view. So yeah, ever since Android 8, the web view runs in a separate process. The memory heap is totally unexposed, they're separate. And then this is an interesting point, the file system access is still exposed. And it's concerning because, like we said, we store the seed on the file system. But by default, the web view does protect it. So the web view is like, is executing JavaScript from the website, and if it sees that you're trying to access the file system, it will say, I'm not executing that.
Is the web view like a part of the OS?
Yeah, it's a native.
So the OS is like in charge of that.
Yeah,
so, okay.
exactly. Yeah.
So that's a separate process, essentially.
Yeah, it's a separate process. It's still inside of this little sandbox thing, so like shares the user, the app's like ID, but not the same process.
So I guess still you would have problem with accessibility and stuff.
That's a good question.
Just look at your screen.
Yeah, whether I would imagine those are. Yeah, I don't know. Actually, so you're asking if it is subject to the same
If the
accessibility.
accessibility applications that you give, like permission to look at your screen, would be able to look at web view.
That's a good question. I actually don't know. I'll have to find out. Yeah, food for thought. Yeah, if it's a separate I imagine there's other special things that might be around this orange box. Might include things like accessibility, but yeah, I feel like running JavaScript from the internet is a generally established scary thing.
Yeah.
So the web view, the developers who are working on this web view might keep that in mind. Because again, this is very
So
important.
you said that the web view JSON process has access to a file system.
Yeah.
Oh,
Yeah. Not by default. You have to tell the web view
how to allow it?
to allow it.
All right.
Which we do not in Fedi.
Basically, BWA stuff.
The what WA?
Like basically the BWA permissions due to the app or to like application.
Yeah, well, PWAs are, I think they work a little differently. Yeah, yeah, that's a totally separate thing. I wasn't prepared to talk about PWAs, but you gave me an idea for more topic information here.
Okay.
But no, it does have access to the file system, but not by default. There's a flag you can set and say, hey, I want websites to be able to access the file system. But yeah, that's scary in our situations. I don't know exactly what part of the file system. In that case, we need to be very careful to allow that because, yeah, like I said, there's sensitive things in the file system. Cool. What else we got here? So yeah, this is a summary of mini app UX, the trust model, extremely high trust in the website you're visiting for privacy mostly. Payment operations, like a website can't just, to our knowledge, can't just pull your money out of your Fedi wallet without you pressing yes, I want you to take all my money. This one, yeah, interesting little point here. So, yeah, it's all about the user, right? So if you have your website and you have, for some reason, you have an iframe running in there, this setup that we have, I don't think it's very resilient to detecting where the message is coming from. So in theory, an iframe could also just throw a post message up to our browser saying that, hey, show them an invoice, pay it. It's just tell them to pay this invoice, and it'll pop up, and the user will see it, but the website itself may not want that. So if you're developing mini apps, you want to be careful about iframes, and there might be a way for us to add a little extra protection there, but yeah, something to look into. Obviously, you're trusting the Fedi app isn't compromised. This is some interesting, if you're interested in security, the React Native WebView library is what imports or makes use of the native WebViews under the hood. So, you know, if there's a bug in there, if there's a bug that accidentally sets that file system access flag to true. No, never NPM packages never get supply chain attacked. So yes, those are some libraries we depend on, and like I mentioned, rooted devices are still high risk. This was something I wanted to research a little bit more. I doubt that like a website, I actually literally still have the LLM prompts. I forgot to read the response, but I asked basically, can a website do anything malicious knowing that it might run on a rooted device? Yeah, I kind of highly doubt it, but it'd be something interesting to know. Because yeah, you'd have to like, I don't know. Again, we're trusting the WebView devs here to not, I don't know, to enforce more boundaries there. Yeah, well, at least you get access to the file system of the app.
You can maybe escape the jailbreak.
Yeah, that'd be something to explore, some jailbreaking.
Definitely want to see other apps.
Yeah. Yeah, I mean, if the rooted device can get around. Let's see what else here. Yeah, coming towards the end. I don't think I even used the whole time, but yeah, if you want to learn some more, all the code's open source. We have released code and unreleased code. We're not building in public yet, but contributions are welcome. If you want to make a PR to this repo, we will look at it and figure out how to work it into the workflow. The Fedi mod browser is what you want to look for in the source code. If you can exploit something, let me know. We don't have a formal bug bounty program, but obviously if you report something, we're definitely going to consider compensating accordingly. So yeah, some plugs, Fedi, B4OS, thanks for bringing me out here. I'm happy you guys with B4OS, but B4OS is great. They run a great program. So yeah, links you didn't already have. That's about it.